Okay. Sorry?
The simplest form of the equation.
The simplest form of the equation?
Yes.
I don't understand what that means. For example, if we say, for example, the function f of x equal x squared. What is its derivative? 2x, huh? For example, the derivative at 1 is then, it's going to be 2, yeah? What does that mean? What does that? The derivative at x equal 1 is equal to 2 for this function x squared. Point? The rate? Absolutely, yes. It actually gives us the rate of how is this function f changing at the point x equal 1. So the function is this. At x equal 1, its value is also 1. And at that point, its derivative is 2. That means it's increasing at the rate of 2. That means when x increases by a small amount, our function will increase by 2 times that amount. So it's the derivative basically gives us an idea about how is this function changing. How is it changing? The rate of change of this function. Now, we also know that when the derivative, for example, is positive in a certain interval, what does that mean about the function? If the function is the derivative is positive in a certain interval, what can we say about the function? It's increasing, yes. It's giving us an idea about where is the function increasing, where is it decreasing, and so on. Derivative is extremely important. It gives us a lot of information about the function f itself. Yeah. So, and also if the derivative is 0, that means on that point maybe we have a local maximum, maybe we have a local minimum, and possibly it's neither maximum nor minimum. So the derivative is extremely important when you study functions. Okay? Now, that's the general idea regarding the derivative. Of course, when you work with derivatives, you have seen some rules. So you know some rules of differentiation. For example, if f of x is x to the power of n, then its derivative will be n x to the power of n minus 1. Yeah, these are the rules. If you have a function u over v and you want its derivative, then I hope you remember the rule.
The derivative of u multiplied by v minus the derivative of v multiplied by u over the v squared.
So, you know these rules? You know what this rule is called? The quotient rule. Yes, the quotient rule. We also have what we call the product rules. U multiplied by v. When you take its derivative, it will be u dash v plus u v dash or prime or v prime. As you know. This is the product rule. And then you have things like len of u. If you want to differentiate len of u, 1 over u, it's actually u dash over u. That means, for example, if your function is len of x squared plus 1, then its derivative will be 2x over x squared plus 1. So this comes from this rule. Finally, another important rule is that if you have your function of the form e to the power of u, and you want to differentiate this, derivative of u multiplied by eu. All of these are really important rules when we differentiate a function. Okay? Now, this is for functions of one variable. Here, of course, last class, we started looking at functions of two variables. What did we talk about last class? What was the domain? Yes, we talked about domains of functions of 2 or 3 variables. Today, we'll talk about derivatives of functions of 2 or 3 variables. However, because we have 2 variables, x and y, then we will have 2 derivatives. Derivative with respect to x and derivative with respect to y. And these are called partial derivatives because there are several variables. So the idea of partial derivative is exactly like the derivative, except that we may talk about derivative with respect to x, or we may talk with derivative with respect to y. Yeah, like that. Finally, let me just mention something here. Suppose you have a constant, for example. Yeah, a is a constant, and multiply it by x to the power of 3. What will be the derivative of this function? A, we keep it there, yes? And then the derivative of x to the power of 3, which is 3. So we could say it's 3a x to the power of 2. So this a is there, you keep it, yeah? It doesn't go anywhere. And you just differentiate x to the power of 3. You will see in a moment why this is important. Another result we will use is, what is the derivative of 1 over x?
Minus 1 over x squared.
Thank you, yes. Minus 1 over x squared. This result also is important. If you memorize it, it will save you a lot of time. So there are some results which are really important. You need to kind of keep them in your mind. You will use them quite a lot. Okay, now I want to go back to these functions of different variables, and I want to look at their partial derivatives. Okay, I will not go through all of this. I just want to go straight to an example and show you how we can work out partial derivative. Here is a function of 2 variables, x and y. Yeah, nice function. What is its domain, by the way? All not real numbers. Not all real numbers. No. Here we have 2 variables, yes? So what is the domain? Is it on the real number? Is it just R? What is the domain? All the plane, x and y. So the whole plane, the whole of R2, you can say the domain of this function is the whole of R2. Do you understand how this is different from saying the domain is all real numbers? All real numbers, if you have only one variable, thank you, yes. With 2 variables, you need to talk about the plane. Maybe it's a circle, maybe it's inside the circle, outside, but it has to be in the plane. Okay, now I want to, what you see here is the way we write the derivative of the function with respect to x. We write it like this, or we can also write it as f with a small x here. So let's find the derivative of this function with respect to x. So we go through each one of these terms. What is the derivative of 3x squared? 6x, yeah? 6x. Then we differentiate x cubed y. Now, here you have to be a bit careful. Y is a constant because we're taking the derivative with respect to x. So y, you should look at it, understand it as a constant like a 5, 6, whatever it may be. So what is the derivative of this then? 3x squared times y, exactly. So, thank you, so plus 3x squared y. And finally, what is the derivative of 4y squared with respect to x? It's like a constant, huh? What is the derivative when you have a constant and you want to take its derivative? What is it? Zero, yes. Zero. Do you understand this? Yeah? So we can add, if you want another rule here, is that when you have a constant a and you differentiate it, it's always zero, yeah? Doesn't matter what this constant is. 10, 20, 30, its derivative will be zero. Now, here, because this term has no x, so it's like a constant with respect to x, so its derivative is zero. So that's how it works. Now, we are also asked to find what is this derivative at the point 1, 0. So I can find now fx at 1, 0. So that means x is 1, y is 0. Substitute. Yeah. So it's going to be 6. Huh? 6 times 1 is 6. And then the other term will give us 0 because y is 0. So this value is 6. That means this 6 is the rate of change of the function at the point 1, 0. In which direction? In the direction of the x-axis. So if we're moving in the direction of the x-axis, our function is increasing at the rate of 6. It's the rate of change in the direction of x. Now, I want to now look at, so that's the derivative with respect to x. Now I want to have a look at the derivative with respect to y. df over dy fy, they're the same thing. You write this or you write this, they're exactly the same. Now let's have a look at this function then. Differentiate it with respect to y. How about 3x squared? What is derivative? 0, yes? There's no y there, so the derivative of that is 0. And then the next term. Okay, what is y then? What is derivative of y with respect to y? 1, yeah? It's like when you differentiate x, what is the derivative of x with respect to x? 1. So here you will get x to the power of 3 and then plus 8y, yes? Everyone okay with 8y? Yes? Derivative of 4y squared with respect to y is basically 8y. So that means the value of this derivative at 2 minus 1, if we substitute, it's going to be 8 minus 8, which will be 0. Do you understand this? Yeah? X is 2, so you substitute here, and y is minus 1, you substitute, and you will get 0. That's basically the value of this. Are we okay with this? Any question at all? No? So, all right. And you can see here actually the rules that I just mentioned, the product rule, and then you have the quotient rule that we already know. All right. Now I have a function here, and I want to find its derivative with respect to x, so df over dx. Now, so this with respect to x, what will be this derivative with respect to x? Yeah, y e x y. Where did the y come from? Where did this y come from? The derivative of xy with respect to x. Yes. So it's the derivative of xy here with respect to x. It will give you the y. It's u dash. Yeah. And then e to the power of u. That's okay. And then x over y. We can differentiate it using the quotient rule if you want, or there are other ways. Let's do it with the quotient rule. If you do it.
Why is that constant?
Sorry?
Why is constant? Why you will use the quotient rule?
Okay. So what do you think the derivative will be?
1 over y.
1 over y, yes. That's fine. But basically, yes, I mean, that's how I did it before. But what you can do here is think of x over y as 1 over y multiplied by x. Yeah? So this is like the constant a we talked about. So yes, you can think of it like this. But if you cannot, yeah, maybe some of you may not be comfortable with this, just use the quotient rule. X over y, in your head, automatically you think, oh, this is u over v. So we can use the quotient rule, no problem. You can do it. So if you do that, let's see what we will get. U dash. What is U dash? Yeah? Come on, girls. I need your attention. 1, yes? Derivative with respect to x of x is 1 multiplied by y minus x times the derivative of y, which is 0 over y squared. So what you are getting, this is nothing. So it's y over y squared, which is 1 over y. It's okay. So it's perfectly fine to do it this way if you want. Or think of it like this. X over y is 1 over y multiplied by x. So it's a constant multiplied by x. So the derivative is just the constant, which is 1 over y. So that's okay too. Yeah. Whatever way you're comfortable with is perfectly okay. Now I want df over dy, df over dy now. Yeah. All right, so again, we have the two terms, exy, the derivative of that with respect to y, x, yeah? Yeah, x, e to the power of xy. Now, the second term, you can use also the quotient rule, or you could use this kind of thinking. It's also fine. But quotient rule, I think, is probably the easiest way to do this for you. So it will be u dash. What is u dash? 0. Yeah, derivative of x is 0. So 0 times y minus x times 1 over y squared, like this. So then this, of course, will be 0. So then you will get x e xy minus x over y squared. And that is the derivative of the function with respect to 1. Does that make sense?
Yeah.
Yes? All right. Now, we talked about derivative with respect to x, derivative with respect to y. These are the first derivatives, but of course you can differentiate again these derivatives, yeah, to get second order partial derivatives. So d to this means the function f differentiated with respect to x how many times? 2 times. So fx, so you differentiate once, you get fx. You differentiate the second time with respect to x, you get fxx. Yes? Same thing with the derivative with respect, second derivative with respect to y. Yeah, you can write it like this, same thing. That's it. Now, if we take df over dx and differentiate it with respect to y, then we're getting fxy. So if you want to find this, how do you find fxy? What do you do first? First we find fx, yes. And then we differentiate what you get with respect to y, like this. So that's what fxy means. First differentiate with respect to x to get this. And then second step, differentiate with respect to y, and this will give you fxy. But we can also have fyx. What happens in fyx? First differentiate with y, and then x. So here, first x, second y. This one, first y, second x. And but in general, for most functions, these two will actually be exactly the same. For most functions, you differentiate with x and then y, or you differentiate with respect to y and then x will give you exactly the same answer. You will get the same result. We will check this in a moment. So fxy is generally the same as f. I think it's given here. You have this theorem. Fxy is actually the same as long as the functions are continuous and so on. So let me come back here and calculate the second order derivatives of this function. So let's do it together again. So what do we want? We want fx first? Okay. All right, so fx. What is it? 2xy, sir? 2xy. 2xy. From this, yeah? And then y cubed? 0. Ln x? 1 over x. So basically, plus 1 over x, yeah? This is fx. Let me do immediately fxx. So I differentiate again with respect to x. So what do I get? 2y, yeah? Very good. And then 1 over x will give us, we already mentioned this a moment ago, and we will get f like this. Now, let's look at fy. Fy? X squared, huh? X squared minus 3y squared. Okay, good. And then f Yeah, then x derivative with respect to y is 0. No problem. Now I want f y y. So the second derivative with respect to y. X squared will give us 0, yeah? 0. And then minus 3y squared minus 6y. Is this it or there are more? Yeah, we need to calculate now f x y and f y x. And we should check that these last derivatives are actually the same. So fxy, that means fx and then derivative of that with respect to y. So look at fx and then differentiate this with respect to y. This will give you fxy. So what is the derivative of fx with respect to y? 2x, yeah? Can you see it's 2x? Because what is derivative of 1 over x with respect to y? 0. So this is 2x. Fyx, so I go to fy and I differentiate it with respect to x. 2x also, that's it. Now, can you see that these two are actually the same? So it doesn't matter, generally speaking, when you want to calculate the second derivative, fxy, fyx, they're exactly the same function. So you don't have to worry whether you want to start with x or y, it's going to be a similar result. Okay, so that is, we're not going to do that. And that is basically this section. All right, I'll just take some time to have a look at some of these questions. So can you try the first one, please? Can you do it? Try it, please, on a piece of paper, and I will come and check. Just the first order this time, yeah? Fx, only we want the first order partial derivatives. Just fx and fy, that's it. Ready done? Okay. And we only want the first derivatives according to the question. It's okay. Yeah, it's fine. This is a 4. This is a 4. You done? How about 4x? This minus 4x. The 2y. remember this minus 4x here is a constant. Yes, this minus 4x is a constant. Remember, when you have a constant and then you multiply it, for example, by y squared, if you want to differentiate this, then it's 2 comes down. A is still there, and the constant should still be there, multiplied by y. So you should not remove the constant, which is here, the minus 4x. It should be there. Yeah. Try the second one if you finish the first one. Read on. Try the second one. Are you done? Okay, just. Try the second. I think you're all fine with this, I guess. Just fx then, yeah. Fx, yeah. Derivative with respect to x, so this will give you 3x squared, and then the second term will give you minus 4 y squared. So the y to the power of 4 will give you 0, so this is fx, and then the fy is minus, this is where maybe some of you were struggling a little bit, so minus 8xy, yeah, and then plus 4y to the power of 3. So please check this, yeah, check your answers. They should be these two answers. Are we okay with this? Yeah? Like that. So let's say we want to do 3 here. So this time, there are a lot of rules you need to use here. Yes? So if you want fx, then what is the first rule you need to use here? The product rule, yes. You need to use the product rule to differentiate the first part of this function. Yeah, so you need to use the product rule. Have you done it? Okay. Can you put these dashes right by f, please, not at the end? Yeah, f dash at x, f dash. Yeah, like this. Yes. Also, please. Can you please write your? I'm not using f dash here. You can notice that because we have several variables x, y, z, we're not using the prime. Yeah, we're not using dash. What are we using? X at the bottom or y, x, y, etc. to indicate that what is written here is the derivative of f with respect to x. I'm not using the dash. Don't use dashes. Fx, fy, yeah, fxx, and so on, like that. All right, so fx here, you need to use the product rule. So it's like two functions of x, u, and v, like this. So it's going to be 2x sine xy, I can put this in bracket if I want, plus x squared then the derivative of sine is cosine. But you have to be careful here that this function is like sine u. What is the derivative of sine u? U prime
Sine u. Cosine u.
cosine u. Yes, very important. So all the rules that you learned in calculus 1, they should be helpful here. You should use them. So here, what is u dash, girls? What is the u dash? Y, exactly. So we need to, there is a y, and then cosine xy. Yeah? And then the derivative of 3 to the y to the power of 3, which will be 0. So that is the derivative with respect to x. And then we find fy, the derivative of f with respect to y. Here, do we need the product rule? No, because x squared is a constant. So just keep it there. X squared is a constant. And then the derivative of sine xy, use the same rule. Use the same rule. But this time with respect to y. So what is u dash in this case? X. Very good. Are we okay with this? So it's going to be x cosine xy. Excellent. And then minus 9y squared. And this one maybe needs a little bit of tidying up. X squared times x is x to the power of 3. Yes? X to the power of 3. Cosine xy minus 9y squared. Like this. Okay, I will leave you 5. I'm not going to do it. 9, 7, 9, same ideas. Let's move on a little bit to 11. So 11, nice, kind, gentle function. Here, no fractions, nothing. So it should be easy to differentiate. Here, we want these 3 second order derivatives. So you want fxx, you want fyy, and you want fxy. So try please. Okay, so try this 11. This, by the way, is fxy. So first with respect to x, and then with respect to y. Now we want fxy.
Doctor on
Okay. We're fine with this, I hope. There is no real difficult thing here. So we want three things. Fx first with respect to x. It's going to be 3x squared minus 4y squared. Huh? So that means fxx, which is this one, yeah, is 6x. That's it. So that's the first answer. The second answer is fyy. So therefore, I need fy, which is minus 8xy. Huh? Yeah. Plus 3. Okay, good. And therefore, fyy is minus 8x. And finally, I want fxy, which is here, yeah, fxy. That means fx, and then differentiate that with respect to y. So it's minus 8y, and that's it. So three answers, this, and this. So these are the three answers we want here. Any question with this? No problem? Yes? Okay. Let me just check what is. Okay, let's do one last one then, please. Let's do this one, and then we can have a small break. Okay, so I want this time this function, and I want to differentiate it. I want these three things. First, before starting differentiating, we can simplify this function a little bit by how can we change this function? Can you see ln of x to the power of 4?
Yes.
I can change this into, what can I do with the 4? Take it out, yes? So this function probably easier if I write it as 4 times ln x. Yeah, remember that the rule of ln of x to the power of r is the same as r ln x. This rule sometimes is really useful to simplify functions. So, and I will leave the rest as it is, 3x squared y to the power of 3 plus 5x tan minus 1 of y, like this. Now, maybe I can start differentiating. I want fx. So, what will be fx? 4 over x, yes? So it's 4 times derivative of ln is 1 over x. So the first term will give us 4 over x. The second term, minus 6 x y to the power of 3, huh? Yeah. And the third term, no need for the product rule, because can you see the x? Anything else is a constant. So what will it be? What will the derivative? 5 tan minus 1 of y. Yeah? There is no need for the product. 5 tan minus 1 of y. Like this. So that's fx. And then I need the fxx. So again, I want to differentiate now this with respect to x. Minus 4 over x squared. Huh? Really important here that the derivative of 1 over x is minus 1 over x squared. And then the second term will give us minus y, 6 to the power of, y to the power of 3. And the third term, 0, yeah? There's no x there, so its derivative is equal to 0. So that is fxx. Now that's the first thing we want. The second is fxy. That means it's the derivative of f with respect to x that I differentiate with respect to y. Now look at fx. The first term is 0, yeah? The second term will give us minus 18 x y to the power of 2, huh? And then, now, what is the derivative of tan minus 1?
Y dash over 1 plus y dash squared.
Okay, but y dash is what?
1.
1, yes. It's basically, remember, the rule is, in general, tan minus 1 of x, its derivative is 1 over 1 plus x squared. If you have u, then of course there will be, yeah, you want to differentiate this, then it's u dash over 1 plus u squared, like this. So here, so it's going to be 5 over 1 plus y squared. So this is fxy, and we want fxyy. So that means I need to look at fxy, and I differentiate it with respect to y again. So basically, look at this and differentiate it with respect to y. So this will give us minus 36 xy, and then we need to differentiate this term with respect to y. You can use the quotient rule. Yeah. You can also use that in general, if you have something like 1 over u and you want to differentiate it, it's actually minus u dash over u squared. You can use this rule here if you want. So it's going to be, or you can use the quotient rule, but let me use this. Let's be a little bit intelligent here. We don't want always to use. So it's going to be minus, the 5 is a constant.
Y.
Then what is the u dash?
2y.
2y. Yes, it's going to be 2y. over
1 plus
1 plus y squared, all of this to the power of 2, like this. So it's going to be minus 336 xy minus 10y over 1 plus y squared like this. Okay, that's basically what is happening here. Are we okay with these partial derivatives? All right. So we'll take a small break, and then we'll come back and do some reviewing and help you with any questions you may have regarding this the test.